In this video, we're going to look at conversion problems. We're going to use dimensional analysis, which, as you'll see here, is a process for converting units. And we're going to try to tie in our understanding of unit ratios and conversion factors to make sense of this process. So when we're thinking about measurement and we're measuring something, we have a desk down here, and we are told that this is 6 feet long. So from end to end, it is 6 feet long. And the whole point of converting things and measuring things is maybe we want to discuss the length of this desk, that's the dimension, the length, using something other than feet. So here we see we have 6 feet, 1, 2, 3, 4, 5, 6. And we're using that foot as our unit of measure. And we want to consider what would this same length be if we didn't use 1 foot, but we used 1 inch instead. And so what we will need to do is to use a conversion factor. Use the ratio, which is just a fancy word there. Ratio and conversion factor are going to be the same. We want to use that relationship. And what we know is that 1 foot is equivalent to 12 inches. That is what's called our conversion factor. And we can write this as a ratio, 1 foot over 12 inches. Or we could write this as the ratio of 12 inches over 1 foot. And so far in this module, we've already seen the idea of ratios and interpreting these values. And I know if I were to divide 1 divided by 12, I would get the number of feet per 1 inch, right? We're getting that unit ratio. Where if I do 12 divided by 1, I get 12. There are 12 inches per 1 foot. And so dimensional analysis is a process to consider changing 1 unit into another. And so there's a couple ways to approach it, but what we're going to do is we want to start with what it is we are looking to change. And in this case, what I'm looking to change is a measure of feet. And I want to change that measure of feet into an equivalent number of inches. So I have to ask myself, do I know the conversion factor between feet and inches? And the answer is yes. I know that 1 foot is 12 inches. So I have that direct connection. And so that's going to be my process here. I want to turn those feet into inches. And this will make a little bit more sense when we have a little bit more of a complicated problem. This is what we would call one-step conversion. I know the relationship between feet and inches, so I'm going to use this conversion factor to convert between that foot, or from feet into inches. And so what we can do is, using multiplication and our conversion factors, I want to start with what I want to change. So I want to convert these 6 feet into something else. And I want to cancel out this unit of feet, and I want to go into a unit of inches. That's what my plan says I'm going to do. That's what I'm going to do. And so multiplication is the key operation here. We want to multiply these 6 feet by a ratio where the feet cancel and I go into a unit of inches. And what I know with dimensional analysis, the focus is kind of on this idea of canceling units. If I want to cancel out feet, then I need to have feet in the denominator of my conversion factor. This ratio here is called a conversion factor. And what I know is 1 foot is equivalent to 12 inches. So if I were to stop right here, feet would cancel, and I would have the total number in inches. Now, let's stop and think about why this makes sense. This is 6 feet. I'm multiplying by this ratio right here. And this ratio, if I were to write this out in words, and we know this is saying 12 inches per 1 foot. So if we're taking 12 inches per 1 foot, and we're multiplying by 6 feet, then that product will give me the total number of inches. So what we did here, dimensional analysis, we start with what we want to change. Think about what we want to go to at the end. If you know the relationship between them, that's great. Make that plan. Then consider what are the conversion factors. that you might need. And again, this problem's a little bit straightforward because we only have one unit to convert into. We don't have any what are called intermediate steps. And then we position that conversion factor so that we have our feet cancel in this case and go into inches. Now, a couple things before we move on to the next example. I think it's going to be really helpful for all examples moving forward is if you can, before you do a calculation, think about whether or not your value at the end of your calculation will be larger or smaller than what you have. And so what I mean by that is, in this problem, we have 6 feet. And what I want to ask myself before I do a calculation is, at the end of my calculation, when I have a unit of inches, am I going to have a numerical value that's larger or smaller than 6? This is a good way to catch any errors that you might make. Now, in my mind, I'm thinking an inch is a much smaller unit of measure. So I know it's going to take a lot of inches to make up 6 feet. So I'm going to have a larger value. And when we do this multiplication, 6 times 12, we get 72. So this is equivalent to 72 inches. Now you may be thinking you just took 6 minutes to explain something that I could have done in my head. And I get that. What we're trying to do here is to think through this process of dimensional analysis using an example that might make sense to you that you can just do so that we can tie our understanding of dimensional analysis to something that we're already comfortable with. Let's look at another example. Here we have a measurement in this case, pounds. We're looking at weight. The dimension we're considering are weight values. And what we want to do is to convert this into grams. Now, I need to think through the calculation here. I want to go from pounds to grams. And so I'm going to make a plan on how I'm going to do that. I'm going to just start by considering I am in pounds, so pounds, and I need to get to, at the end of my calculation, I need grams. Now, I don't know off the top of my head, and in the conversion document that we're given, the common conversions, this is not one that typically you need to know. Now, on that document, though, I do have a conversion from pounds into kilograms. And I have a conversion from kilograms into grams. And so that's going to be my plan here. I want to convert these pounds into kilograms, because if I can convert them into kilograms, I can go into grams. And the great thing about dimensional analysis, it's very easy to go into some unit and then out of it right away. Because we're thinking about canceling, multiplying by a conversion factor, it's very quick to go into one and another. And what we have in this particular situation is kilograms is what I refer to as an intermediate step or an intermediate unit. It's kind of linking pounds and grams. And so if I want to go from pounds and convert that into kilograms and then convert those kilograms into grams, I'm going to need multiple conversion factors. I need to know the relationship between pounds and kilograms, and I need to know the relationship between kilograms and grams. And what I know 1 kilogram is 1,000 grams, and I know there are 2.2, and this is an approximate value, there are 2.2 pounds in 1 kilogram. So these are the conversion factors that I need to use in order to complete this plan. Okay, now before I do the calculation, I want to think about whether or not I'm going to have a smaller number or a larger number at the end. So I'm starting with pounds. A gram is much, much smaller. If I would rather, I always ask the question to students, would you rather have a pound of gold or a gram of gold? And hopefully you will say pound. A pound is much heavier. So if you think about a gram being a much smaller unit, there are a lot of grams in those pounds, right? There's many, many grams So we're going to have a much larger value at the end of our calculation. So with my dimensional analysis, I'm ready to go. I'm going to start with what I want to change. I want to change the 184 pounds, and I want to multiply by a conversion factor. And according to my plan, the first thing I wanted to do was go from pounds into kilograms. So that means when I'm multiplying, I want to cancel out these pounds and go into kilograms, just focusing on the units first. According to my conversion factor that I've already thought through, I know there are 2.2 pounds in 1 kilogram. Now, if I were to stop right now, pounds would cancel, and I would have my value in kilograms. But I don't have to stop right now, and that's the great thing about dimensional analysis, is I can just keep going because I want to eventually go into grams. That's what I want to do. I don't want kilograms, I want grams. So instead of stopping right now, let's just multiply by another conversion factor. Specifically, the one, according to my plan, that converts kilograms into grams. I want to cancel out kilograms and go into grams. So you see that there's this domino-like pattern that approaches the result where we're canceling out units and wanting to get into our final unit. And because I've already thought through my units, I know 1,000 grams is equivalent to 1 kilogram. So I have that conversion factor. I am now ready, because I'm in the unit of gram, I'm going to multiply all the numerators. So multiply all the numerators. And it looks like you get 184,000. And I want to multiply the denominator, so this is just kind of over a 1, a floating 1. 1 times 2.2 times 1 is 2.2. And so now in my calculator, I'm going to type 184,000, and I'm going to divide that by 2.2. And I'm going to write this out a little bit. You get 83,636.36 repeating. Let's round this to the hundredths place. So this would be 83,636.36 grams. That's a lot of grams, and that's what I expected. Because it's such a smaller unit, I knew I was going to have a much larger value. Let's look at one more example. In this problem, we want to convert 750 milliliters of iced tea into an equivalent number of cups. Now, if I'm thinking about my plan, a milliliter, and ultimately I want to end up at cups, so I know where I'm starting and I know what I want to get to. Now, a good thing to think about in this problem is, what's the dimension? Are we talking about weight? Are we talking about length or time? And here we're talking about volume, because we're talking about the amount, the capacity that we have. So this is a measure of volume, which means I should not be involving ounces or anything else involving weight or length. I need to focus on volume. Now, on the constant conversions, you might know the number of mLs or the milliliters in a cup, but if you don't, there is one that is an intermediate step. So if you want to pause the video now and think through what is the intermediate step between mLs and cups, go ahead and pause it. What we can do, common conversion, go from mLs to ounces, and then ounces into cups. If you go on to take clinical math, Math 150, or if you're in clinical math, Math 150, these are the conversions to memorize. These are ones that we use quite frequently. So I'm starting with mLs. I want to end up with cups. I've already made a plan of how I'm going to do that. Now I want to write out what my conversion factors are. I know there are 30 mLs in 1 ounce. So that's one conversion factor I need. In order to go from mLs to ounces, I'm going to use that conversion factor. And then to go from ounces into cups, I need to use the conversion factor, the relationship between those. And I know 1 cup is equivalent to 8 ounces. Very common mistake here is involving 16 ounces. But these are fluid ounces. This is not weight. This is fluid ounces. So I'm starting with what I want to change, 750 mLs. If you want to write that over 1 as a placeholder, that's fine. Now, if you want to pause the video, go ahead and try to line up your units. First going from mLs to ounces. We want to cancel mLs, go into ounces, and then we want to cancel out ounces and go into cups. Just based on that, I know mLs we want to cancel that and go into ounces because that's what my first plan was. First step of the plan. And so when I do that, I can use my conversion factor that I've already written out. Because I am in and I'm using dimensional analysis, I don't have to stop here. I have ounces right now. If I were to stop, I would have ounces, but I want to keep going because I want to cancel out those ounces and go into cups. And I know if I do that, ounces will cancel and I'll have cups. The relationship between these, I know 1 cup is 8 ounces. I am now ready to finish this calculation. Multiply the numerators. 750 times 1 times 1 is just 750. And if you multiply the denominators here, 1 times 30 times 8 is 240. So what we get, 750 divided by 240, you get exactly 3.125. And the unit here, cups. Now, depending on how you're asked to round, very different, could be different for the situation. So maybe what we see in our homework is a consistent round to the hundredths. So if we round this to the hundredths, it would be 3.13, approximately 3.13 cups. As we think through this video, I know it was a long video. Dimensional analysis is a process to change units, convert units, thinking about and canceling one unit and going into another. And the placement of those units in the dimensional analysis process is very important, focusing on canceling, going into another. Another key fact is we have multiplication between all of these conversion factors. And if we were to stop and interpret each of these ratios, each one of these could be considered and interpreted as a unit ratio. So 1 over 30, if you get that small number, that's the number of ounces per mLs. So multiplying that by the number of mLs gives us the number of ounces. Final thing to take away here, make a plan. Think through the process and the dimensional analysis before you start to write any sort of math. Make a plan with the units. If you make the plan and you then write out the conversion factors that you need, you've literally done about 75% of the work. You just need to now place them in the right place, stop at the end to determine whether or not you think that is an appropriate value, and then check your work, and you're done.